Hello and good day to everyone. We are from Universiti Putra, Malaysia. Today, I am going to present to you our research entitled Mapping of Black Pepper Farm using Landsat 8 OLI and Supervised Classification. This project was conducted by a team that consists of 3 students under the supervision of 1 lecturer. As an introduction, the idea of mapping black pepper farm comes as we could see how the Earth observation has grown tremendously. Freely available satellite data such as Landsat 8 also leads towards a better prospect in agriculture monitoring and management. It is also proved that mapping through remotely sensed data is a well-known geospatial method for agriculture monitoring, and it enhances the crop production through these monitoring activities. However, most studies and research on remote sensing and Earth observation were done on large-scale agriculture sectors such as oil palm and paddy, especially in Malaysia. In addition, the COVID-19 pandemic that occurred in 2020 jeopardized not only large-scale agriculture activities but also the small-scale activities. Therefore, this study was done on black pepper since limited studies on geospatial technology was done on this crop, and this crop also can represent the small-scale agriculture activities in Sarawak and Malaysia. In order to complete the idea of this research, 2 objectives were constructed, which are to mapping the black pepper farm using Landsat 8 and supervised classification with limited ground truth data, and to create a base map for black pepper farm in Kampung Bukit, Sungai Pelan, Bintulu, Sarawak. Kampung Bukit Sungai Pelan is chosen as study area since this site is targeted by Malaysian Paper Board as rancangan tanaman berkelompok in Bintulu. This means it will be used as reference on black pepper cultivation, especially in Bintulu. Next, ground truthing was done using GPS Garmin 64S to collect the coordinates of the point of interest and the area of interest in this study. All this will be used and referred during image processing procedures. Satellite images used in this study are retrieved from Landsat 8 OLI Level 1 Precision Terrain 1, and all these images were downloaded from USGS website since it is freely available. 4 scenes were used in this study, which are from August 2019, May, June, and July 2020. The scenes from August 2019 is used as a reference before the study was conducted, while May, June, and July 2020 is chosen since the scenes has clear image on our area of interest from clouds and shadows. To accomplish our objective in mapping the black pepper farm, 3 processes were done, which are image pre-processing, image processing, and the accuracy assessment. In doing so, we are using NV 5.3, ArcGIS 10.4, and Google Earth Pro software. In pre-processing, we conducted radiometric, atmospheric correction, reprojection, image enhancement, and subset. This is important in order to reduce the noise and increase the image qualities. Whilst in image processing, we use 2 classifiers, which are maximum likelihood and also support vector machine. In order to conduct this classification, 6 training samples were built, which are residential, vegetation, water, crop, land, and road. Processed image were then evaluated using overall accuracy and also kappa coefficient. From all the results, then finalized map of black pepper farm can be obtained. In image pre-processing, we use pen sharpening as our image enhancement in order to obtain higher accuracy of image obtained from Landsat 8 OLI. We use panchromatic band in order to obtain clearer image, as you can see on the screen at the right side, where it shows a clear image of road rather than the image without pen sharpen on the left side. For training samples, 6 classes were developed, which are residential, vegetation, water, crop, land, and road, and the representative colors are as shown on the screen. All these samples are used in the classifiers of maximum likelihood and also support vector machine. All processes image will be evaluated using overall accuracy and kappa coefficients using following formulas. As a results and discussion, we will compare the results from maximum likelihood and support vector machine classifiers. As we can see on the screen, both classifiers show difference in the image process. For example, in maximum likelihood, we could see even we are using 6 training samples, some image only classifies into 5 classes. For example, in August 2019, there is no land identified in the image, whilst in support vector machine, it shows the difference of land from month to month. Besides, in maximum likelihood, we could see there is slightly different between roads and residential, which make it harder for us to identify which one is road and also residential. Whilst in support vector machine, we can see it is better classified between residential area and the road. Therefore, it shows that support vector machine give us a better accuracy in this classification. As we go through support vector machine results on our study area, it shows that the growth of crop along the month is observed, hence positive growth is detected. Also, there is expanded area on exposed land, shows deforestation activity were conducted at the forest nearby the farm. The accuracy assessment for both overall accuracy and kappa coefficient of support vector machines shows that it has higher accuracy than maximum likelihood. Then, from the classification results, we are able to create a base map for Black Pepper Farm Kampung Bukit Sungai Pelan Bintulu. As a conclusion and recommendation, it is proved that accuracy of Landsat 8 OLI using support vector machine and maximum likelihood gives a better precision using support vector machine. Through the results generated from image classification and mapping in this research, data can be future processed to monitor the growth and productivity of black pepper. With that, thank you for your time and see you again.